Okay, everyone. 2.7, multiplying special cases. Pretty much tells you the story right here of today's video, today's lesson. The really good news here is that this is essentially the same thing we were doing last section. There's barely any difference at all. And on a certain level, no difference. So here we go. See for yourself. If we were to multiply these two binomials together, wouldn't we need to distribute the x through that other bubble? So x times x is x squared, and then x times negative 4 is negative 4x. But then we also have to distribute this 4, this positive 4. 4 times x is positive 4x, and then positive 4 times negative 4 is negative 16. And then, of course, what? You're supposed to look for any like terms that combine. Just so happens that there usually are. And, oh, look at this. What's negative 4x plus 4x? Wouldn't that be 0x? Or like 0, it's gone? So yeah, the final answer is x squared minus 16. You shouldn't even write 0x. It's just gone. Look here. Let's see what happens here. So k times k, and then k times 7, and then negative 7 times k, and then negative 7 times 7. Remember, you can call this FOIL when you're doing a binomial times a binomial. When you do this, it's the firsts, and then the outers, and then the inners, and then the lasts. FOIL, FOIL. Firsts, outers, inners, lasts. And then, looks like we have a couple of terms that kind of cancel out again. Plus 7k minus 7k. That's gone. That's 0k. And so the final answer is k squared minus 49. You're starting to see a pattern here. Maybe why this section is called special cases. Why is this happening? Right? I mean, and I don't think it takes too much analysis. It doesn't take a genius to see how, these bubbles are the same except for one's plus, one's minus. It starts the same, but it's that one's in the middle with a minus and the other's plus. And yeah, so when you have the exact same binomial except for that sign in the middle, you're going to get these two middle terms that are going to cancel out, when you add them as like terms. Is it going to happen here? Are these the two exact same bubbles except this is plus and this is minus? You betcha. So firsts, outers, inners. You see? The outers, it's a 2x and a 3, except there's a negative. And then I said outers, right? The outers, it's a 2x and a 3. The inners, again, because the bubbles are so similar to each other, except for the plus and minus, the inners is also multiplying a 3 and a 2x. But this time, because the plus, it's going to be plus. And so that's what creates these two terms that are going to completely just add up to 0 and be gone. But don't forget, we still have to do this, right? The L in FOIL. And since we're multiplying, negative 9. So once again, they cancel out, and you're just left with the 4x squared and the minus 9. Same exact thing here. I mean, just beating a dead drum. Beating a dead drum? What the heck was that? Sorry. Beating a dead horse, I guess, or just... That was a weird mix of expressions that I just said. So 3n times 3n, 3n squared. Then we have a plus 3n and a minus 3n, just like that, outers and inners. And then what's negative 1 times positive 1? Well, it's negative 1. And of course, because of the relationship between the two bubbles, the two binomials, these two cancel each other out, and you're just left with that. So right here, you don't have to write anything down, or unless you want to, but why do you think multiplying problems like this are considered special case? Well, we already talked about that. Because the bubbles are basically the same except for the plus and minus, which makes these middle terms eventually, when you FOIL it out, they cancel. Is there a pattern here that you can use to your advantage? Could you almost bypass over this middle step and just know exactly what the final answer is going to be because you've picked up on a pattern, and it's almost like you've made it almost like into a formula where if you have bubbles like these, you can almost jump right to the final answer? Yeah, but I don't know if I'd recommend doing that necessarily. I'm just saying that you could easily do that. You could easily go, well, I know what's going to happen, and I know it's just going to be, this 3n times itself, and then this negative 1 times the positive 1, but okay. Switching to like the other part of this lesson, here's what we're doing. These questions right here in front of you now, they probably look easy enough. Explain what it means to raise something to the second power. Yeah, but what this is leading to is the types of problems that people misplay and screw up all the time. It's leading to problems that, if I made a top 5 list of common bad algebra habits, what it'd be this. It'd be what this is leading to. This stuff. So just really quick, let's remind ourselves, what does it mean? What does this mean? 5 to the second power. What does it mean? Well, it means 5 times 5. When you square a number, you multiply by itself. What does negative 3 squared mean? Negative 3 times negative 3. What does x squared mean? X times x. When you square a bubble like this, it means you multiply it by itself, right? In fact, whatever squared, it doesn't matter what's in the parentheses, it's whatever times itself, another one of these. Okay? So here, let's just cut to the chase. There is a certain way that people screw this up, and they look at this, and their first instinct might be wrong. Here's what you have to do. You have to look at this and go, oh, we're squaring this bubble. It means we're going to multiply this x plus 8 times another factor, another binomial factor of x plus 8. Write it like this, because then it'll be a little more clear, a little more obvious to you that how you're supposed to do this is foiling, distributing the x to here and also to the 8, and then distributing this to here and to here. So x times x, x squared, x times 8, plus 8x. Looks like we're going to get, see, now these bubbles are exactly the same. So we're not going to get a minus 8x. It's not going to cancel. It's going to be another 8x for the inners. And then the lasts, as we finish distributing the 8, positive 8 times positive 8, 64. And like I said a minute ago, or a second ago, or 10 seconds ago, whatever it was, these don't cancel out. They add up to be plus 16x. Okay? And then likewise here, what does it mean to square this bubble? It means multiply it by itself. I'd write it all out like this, because then it's, like distribute to be 9x squared, and then what? Minus 15x, we're multiplying. Another minus, hey, I'm picking up on a pattern here. Minus 15x again, and then negative 5 times negative 5 is positive 25. Okay? And then these combine to be what? What's negative 15x minus 15x? Well, it's minus 30x, of course. So maybe a couple things, a couple comments before we move on, okay? I almost don't want to say it out loud, but the mistake that people make when they're doing this, they just look at this and it's being squared, and they want to just go, oh, well, let's just square the x, and let's just square the 8, and that's it, right? Wrong. This is not where you're able to get away with that shortcut. You cannot just distribute the power when it's this. Now, I'm not going to pretend that this one right here isn't the other way around. Like, look, because of what this, ends up happening, because of what ends up happening here, you actually can just distribute the power, and it's because it's really just going to be 4 squared, x to the 3rd squared, and then y squared. So you actually can do it here as a shortcut, but you cannot do it here. And what's the black and white reason? It's pretty straightforward. When there's more than one term in the bubble, like whatever you're squaring, whatever bubble you're squaring, there's 2 terms here. Here, this is technically just 1 term. It's all just being multiplied together. So you actually can do this shortcut here when there's only 1 term, but not here. So likewise, when you're doing, come on, a little bit of scratch work there maybe. So you should do that first, because then you can see how it's going to be all of this distributing 4x squared plus 2x, another plus 2x, and then what's positive 1 times positive 1? It's another positive 1, of course. So, I mean, you could also sort of come up with like a pattern or like a formulaic shortcut here where it's like, oh, if it's the same 2 bubbles, I could figure out it wouldn't be as simple, but there is kind of a formulaic way to take this original problem and be able to jump ahead all the way to like the final answer. There is a formulaic pattern to it. Like, I know already in my head that this final answer is going to be x squared minus 14x plus 49. Because it's like the same thing happens. You can almost make a formula out of it when it's the same 2 bubbles, just like you could make a formula out of when it's almost the same 2 bubbles. It's just that one's plus and one's minus. But hey, I guess probably all to say about that. Thank you for following along. What was that? 2.7. So, I guess what's next is, I don't know, 2.8. Maybe I'll see you there.